The first example of how MTC ChromaWarp works shows how to solve a problem with this image. This statement may upset the photographer because I've called what is probably a deliberate choice a problem. The intense orange light illuminating the subject on the left side of the photo. The beauty of photography is that we can give different interpretations of the same image, so I will start from the assumption that I want to make the skin tone more uniform. I'll start with one thing. Sometimes it's not easy to understand what color we are actually looking at. The areas of the subject illuminated by the sidelight not only appear more saturated, but also have a different hue. Beginners, in particular, may need a little help to focus on the problems, so here's a suggestion. Let's create an empty layer and fill it with 50% gray, changing the blend mode from normal to luminosity. What we see is the color of the image below, understood as a combination of hue and saturation, but without any variation in brightness, because this is taken from the layer we have created and is uniform. In many cases, this allows us to better understand what colors we are looking at. For example, it makes it clear that part of the model's dress has a blue component, which was not obvious when looking at the original. In this case, I don't think it's necessary to intervene on more than one color. The aim is to reduce the effect of the orange light. So, let's select the point relating to orange. It's probably quite close to the color we're interested in, but we have no guarantee that it has the same hue. So, let's define a new input color by double-clicking on the square. And let's sample the illuminated part of the skin tone. This will become the new input color. If we click on the square, the output color is set to be identical to the input color. If, on the other hand, we had clicked on the rectangle on the left, the output color would have remained the original one. We therefore have two options, which are worth remembering. Click on the rectangle on the right and sample a point on the skin, more or less here. The logic is to bring the original input color closer to this one to make the image more homogeneous. Before proceeding, observe the position of the ray in the color wheel. Clicking OK gives us this result. It is excessive, but let's note two things. The first is the position of the ray. Not only has the color been desaturated because the point has moved towards the center, but it has also changed hue. The second is that the brightness has also changed. We can adjust the hue and saturation by moving the point in the circle, but we know that brightness is not directly accessible from the color wheel. However, we have the slider called P in the panel below, which controls a particular form of brightness called perceived brightness. The adjective perceived indicates that the model tries to approximate human perception, which is not the case in other models such as HSB and HSL. This specific model is called HSP. Moving the slider to the right lightens the output color. Moving it to the left darkens it. We can also use the sliders to adjust the hue and saturation if we wish, in order to achieve a result that we are happy with. If we reactivate the auxiliary layer created earlier, we can check the extent of our correction. Don't forget that if we want to reduce the effect overall, leaving part of the original image visible, we can still use opacity. This is a basic philosophy. We can exaggerate the correction and then go back if we want, mixing the corrected version with the original. This example was very simple, as you have seen. Let's try working on a more challenging image.